Okay, the Riemann sum method. So as we get thinking about these, one of our big goals is going to be to find areas underneath curves. All right, areas between the curve and the x-axis. So as we get going on this, one method we can utilize is referred to as the Riemann sum method. And what that entails is drawing from the x-axis up to the graph, and then it could be left-hand endpoints, right-hand endpoints, it could be a midpoint like this, although we don't go into those too much in this class. All right, but basically you draw up to the graph, and then you draw a rectangle that's going to have some predetermined sort of width, or we tend to have the exact same width on all of our rectangles, but it's still using the method if we make them different sizes. All right, so let's try this example. We would like to estimate what's the area underneath the curve, between the curve and the x-axis on the left-hand graph, but they've gone ahead and drawn in some rectangles for us. So they drew it up from 3, as you can see here. They went up from 3 to the curve, and they probably chose that because it works out to a nice integer value over here. All right, and then they drew their rectangle both to the left and to the right from there. And then they drew another one up from 5 till it got to the graph, and then they came over to 4 where the previous one ended. So what our goal is to do is get an estimation of the area underneath this curve by calculating the areas of these rectangles and then adding them together. Well, the area of a rectangle is going to be base times height. So the first rectangle I'm going to be looking at has a base of 2, and it looks like it has a height of 3. Gets up to 3 going across here at the top. All right, so 3 times 2 makes 6 for the area of that rectangle. The other rectangle is only 1 wide, but it looks like it's 5 tall. So 1 times 5 makes 5. 6 plus 5 is going to be 11. Now, how accurate of an estimation is that? That's the best we can do based on the rectangles they gave us. But let's take a look at our graph real quick. We had a little bit of an overestimation for this region that we counted right into our total, but it was above the graph. So that's an overestimation. We had a little overestimation here at the top as well, but we had a significant underestimation in the middle, this part that was not accounted for as we were doing those areas. So you just have to be a little bit careful on these. Shouldn't be too bad. It is just base times height or length times width to get the area of these rectangles. Add them together and you've got an estimation for your area.